Welcome back to Prep Station, UTME 2025 Physics. Okay, let's quickly attempt some past questions on what we have learned so far. Okay, which of the following is true of light and sound waves? They both transmit energy. They both need a medium for propagation. They are both transverse. Their velocities in the air are equal. Which of the following is true for light and sound wave? Which of the following? They both transmit energy. Okay, they both need a medium for propagation. That's not true, because light waves falls under electromagnetic that does not require medium. Sound wave falls under mechanical, so this cannot be true. They are both transverse wave. That is not also true. Sound wave is longitudinal. Their velocities in the air are equal. That is not also true. The velocity of sound in air is 342, depending on the temperature, while the velocity of light is 3 times 10 raised to the power 8. That is 300 million meters per second. So the correct answer here should be they both transmit energy. Okay, let's move forward. The equation of wave traveling along the positive x direction is given by this. Determine the angular frequency of the wave. Determine the angular frequency of the wave. 2 pi over lambda. Okay, so here we have omega t, and then here we have kx. So there is a formula for solving this. All you need to do, just break this down. This represents the amplitude, and then here you have 2 pi ft will handle this one, and then here you have kx, where k is equal to 2 pi over lambda. So if you apply that to this question can be solved. So all I need to do is to say 2 pi over lambda equals to 2 pi x over lambda equals to 0.025x. So x cancel x, and then from here I can find my way out by calculating what? The angular frequency. All right, let's move. Okay, let's move. From the equation above, 500t is equal to omega t. All right, so if you do that, omega equals to 500. So 5 times 10 raised to the power 2 radians per second. So that is how we got this answer. So let's move forward. Given the progressive wave equation, y equals to this, calculate the length. Calculate the length. Okay, the answer here is 15.7. I think that has been solved already. From the expression above, 0.4x is equal to kx. That is from here. 0.4x is equal to kx. So if you make k the subject of the formula, calculate the wavelength. From there, k equals to 2 pi over lambda. So from this, you can find your answer as 15.71. Okay, let's move quickly. The sound of electricity bell dies down slowly when air is slowly pumped out from the bottle because, now this is sound of electric bell. Sound falls under mechanical waves. Mechanical waves need material medium for their propagation. So if you pump out air, that means that space has automatically becomes what? A vacuum. And sound cannot travel through vacuum. So sound needs a material medium. That is the answer. If light waves has a wavelength of 500 nanometer in air, what is the frequency of the wave? What is the frequency of the wave? If light wave has a wavelength of 500 nanometer, so simply apply the formula for wave. V equals to F lambda, F equals to V over lambda, and then that will give you the answer. So let's move quickly. Okay. Yep, so that will give you the answer. So we move quickly. Ripples on water and light waves are similar because both have the same frequency. Ripples on water and light waves are similar because both can be refracted and diffracted. Our longitudinal waves have the same velocity. They don't have the same velocity. So the right answer will be can be refracted and diffracted. Now, why this is correct is because we have 5 properties of wave. So anything that is categorized as wave must pass through these 5 properties of R squared D. The first R here is for reflection. The second R is for refraction. The D is for diffraction. I for interference. P for polarization. So both can be refracted and diffracted. Let's move quickly. A progressive wave is represented by these 2 layers of the wave separated by 153 cm and phase difference of these. Now the formula for phase difference according to this equation is 2 pi x over lambda, and that is equivalent to what you have here, pi x over 34. Okay, so what are we looking for? The phase difference. Have a phase difference. So the phase difference from this, if you make theta the subject of the formula, and then you go through 2 pi times 153. Now 153 is separated by this, that is x. 153, then lambda is 68. Lambda is 68 from the calculation here. Okay, lambda is 68. So when you do all of that and substitute, you are going to get your answer as 90 degrees. So phase difference of 90 degrees. So let's move quickly. The equation of a wave traveling along the positive x direction is given by this. Determine the angular velocity of the wave motion. Determine the angular velocity of the wave motion. That is also simple. This is 2 pi. This is kx, and k is the same thing as 2 pi over lambda. This is omega t. So all I need to do, since I'm looking for angular velocity is denoted by omega. So I just pick this and then use it to represent omega, then make omega the subject of the formula to get my answer as 500. A tuning fork having a frequency of 3128 emits a wave which has a wavelength of this. Calculate the velocity of sound. You know this formula already? V equals to F lambda. Frequency was given as 312. Lambda is what we are looking for. Is it lambda? Let's see. Frequency. No, lambda was given wavelength as 1.1. So all I need to do, substitute this into the formula to get your velocity. All right, so that is the answer. 2022, the last question. The main factor which affects the speed of sound wave is what? The main factor which affects the speed of sound wave is what? Okay, that will be properties of the medium. I explained that before, properties of the medium. Now, the sound wave, the range of sound waves differs based on the environment and based on the temperature. You have it from 330 meters per second to 342 meters per second, depending on the temperature of the medium. All right, so let's quickly look at the characteristics and properties of waves. Characteristics and properties of waves. I've already given you the 5 properties, so we just look at it one after the other. The 5 properties, if you remember, R squared D. So R, the first R is for reflection. The second is for refraction. Okay, and then D is for diffraction. I is for interference. And then the last one, P, is polarization. All right, so these are the 5 items we are going to consider in this lesson, the 5 properties of waves. So let's quickly move forward. So we have reflection, refraction, diffraction, and interference of plane polarization. Then we have superposition of waves, interference, beat, and then Doppler effect. Okay. To study the properties of waves in the laboratory or in any environment, you need a very simple device called a ripple tank. This diagram is the diagram for ripple tank, okay? So it consists of electric motor to move what is called the dipper, and then it has a glass where you have pool of water inside, and then you have a screen, or simply you can use paper to see the shadow of whatever that is happening in that pool of water in the glass. So this is a ripple tank. It can be connected to a power supply depending on the nature of the motor, or simply to a DC source. So I'll just pass by. That is what a ripple tank represents. Now, characteristics and properties. We're looking at reflection. What is reflection? In a very simple terms, reflection simply means to bounce back, bouncing back of wave, okay? It is, what do you think will happen if a barrier is placed in front of the water wave? Now, this is a ripple tank, this is a paddle to cause ripple. So what will happen? Now, that is wave being produced by the paddle. So if you put a barrier in front of that ripple tank, what happens? You see the dotted line, the dashed line represents reflection. So this wave will be reflected back, okay? So it is a plane barrier, then the waves will be seen to bounce back. This is called what? Reflection, bouncing back of wave, as you can see. All right. Now, refraction. What will happen if we put a barrier to block the wave in the same ripple tank? The change in the depth of the water wave causes a change in the speed of the wave, as well as decrease in the wavelength. Now, let me show you this first. Look at that. All right. Now, this is the wave traveling down here, but getting to the barrier, you can see the wavelength decreases, and then after passing the barrier, it returns back to normal. So what has happened here is change of speed. So change of speed of wave is what is called refraction. So you can define refraction as what? The change in speed of wave when it comes across what? Barrier, or across the boundary of two media with different density. So what happens here is density. The density of the water here is different from the density of the water here. This one is deep, but this one is shallow because of the barrier. So that results to refraction. Now let's go to diffraction. What is diffraction? I will use the same ripple tank to explain this. Here we have a barrier, but it's not completely closed. There is an opening. So if I produce wave with a paddle, what will happen? Let's see. Look at the wave being produced. Now, as it gets to the barrier, what happens? It diffracts. It diffracts. It changes the direction. It changes the form. So, what is diffraction? Now, what will happen if the width of the gap in the barrier is similar? Okay, let's continue this illustration. What happens if we increase the gap? Let's see again. If you increase the gap, what will happen? Okay, the wave will still diffract, but this time around the diffraction is not much. Diffraction means the bending of the wave. This time around is not much, it's a little bit. Why? Because the opening is wide. What does that mean? The width of the opening is proportional to diffraction. That means increase in the width will reduce diffraction. So it's an inverse proportion. If you decrease the width, the diffraction will increase. So from the illustration above, diffraction depends on what? The wavelength of the wave and the size of the opening. See that now? And the size of the opening. So diffraction depends on the size of the opening. Okay, so let's move forward. The next one, I've explained reflection, I've explained refraction, I've explained diffraction. Now is interference. What is interference? When two waves meet, they interfere with each other. If they meet each other exactly in phase, The amplitudes add up to produce large crest and large trough. Okay, so this diagram represents two waves. So if two waves meet, they produce a larger wave. For interference is the combination, the word interfere is the overlapping of two waves. So this illustration is showing the overlapping of two waves. You have wave 1, wave 2. So the interference or the overlapping of two waves has given rise to what? A larger wave. So if two waves interfere and then you have a larger wave, it means the nature of interference form is called constructive interference. Constructive. Okay? When two waves interfere to give you a larger wave, you call it constructive interference. So let's move. Look at it now. This is called constructive interference. Okay? In a situation where two waves interfere, meet, overlap to form a bigger wave, we call it constructive interference. Let's look at another scenario. Okay, so what happens if we have two waves meet and they are in opposite direction? Now, how do you know that they are in opposite direction? Let me go back. Let me show you something. Now, look at this one. The movement of this wave and the movement of this wave is the same. Where you have the crest of this wave is the same as the crest of this wave. Where you have the trough is the same as the trough of this wave. So if I merge these two waves together, they will just align. Now look at the next one. Now the next diagram, see what happened. See what happened now. Now where you have the crest of this wave is in alignment with the trough. And where you have the trough is in alignment with the crest. So that is to say they are traveling in opposite direction. So if you go with this, what happens is they will simply cancel out. This is what I mean. Now, if you go with this, if I align this wave with this is what will happen. Now look at this wave. This is what will happen. So when this happens, it means they cancel out. Why? Because according to the calculation of wave, up is +1 and then down is -1. So +1 minus 1 is 0. So you have up crest, down trough, so this cancel out. So if I'm viewing this wave through a device called oscilloscope, it's a device used in viewing wave. Although where we can find it very common in this side of the planet is in the hospital, where they use it in checking, people's pulse to see if the heart is still beating and all of that. So if I view this through oscilloscope, this is what I will see under the oscilloscope. So this is called destructive interference. Why? Because the overlapping has resulted in nothing. So this is called destructive interference. Let's move. Okay, let's quickly look at a few questions before we round this up. Which of the following characteristics of wave is used in the measurement of the depth of the sea? Which of these characteristics? Now the answer should be reflection. Now, why is it reflection? Now, to measure the depth of the sea, there is something called sonar under the ship. It's a device with something like this. This is the sea, this is the sea, this is the sea. So here you have the sea bed. So the sonar is a device that sends signal to the sea bed, and then the other part of the sonar receive the reflection. Okay, so with that, you can now measure the depth of the seabed using the formula for echo. So I think the answer for this should be reflection, because for this signal to travel to the seabed and come back, that is reflection. Why? Because by definition, reflection is what? The bouncing back of wave. Okay, the bouncing back of wave. So the answer is reflection. Let's move. Which of the following is the exclusive property of a transverse wave? Exclusive properties of a transverse wave. The answer is polarization. Sound wave cannot be polarized because sound wave is longitudinal. But light waves and any other waves that are under transverse can be polarized. By the way, what is polarization? Is the confinement of wave to travel in a particular direction. The difference between sound waves and light waves is that sound waves, I explained that before, okay, So sound wave falls under mechanical waves, light waves falls under electromagnetic wave. This is mechanical because it requires medium for traveling. This is electromagnetic because it can go through vacuum. So what should be the answer for this question with that? So the answer is require a medium to travel while light waves does not. So I've already explained that here. So light wave does not require a medium. It can go through vacuum. And that is why signal transmission is possible in space. Okay? Because there is vacuum and signal does not require that. So the property that is propagated in a traveling wave is energy. Yes, I explained that before. What is wave? Wave is a disturbance that travels through a medium for just one purpose, to transfer energy. So the property that is propagated in traveling wave is simply what? Energy. The distance between two successive throbs of a wave is 0.4 meter. If the frequency of the source is this, calculate the speed. This is a simple question. Just go through the wave formula. V equals to F lambda. Okay? And then make V the subject of the formula. That will give you the answer, as you can see. Because frequency was given, that is F, frequency was given, and then wavelength was also given, which is lambda. So the formula is V equals to F lambda. Substitute, you get your answer. So let's move. Okay, that will give us 330. The distance between two successive throbs of a wave is 0.4. If the frequency of the source is this, calculate the speed. The same thing. The distance between two successive throbs. Now, do you remember that this represents wavelength? The distance between crest or distance between trough is called wavelength. So that means we have lambda, and then the frequency we have F. So calculating V will be very simple. Calculating V will be very simple. Then, which of the following properties is not exhibited by sound waves? I said that before. Sound wave cannot undergo polarization because it's a longitudinal wave. It's only light wave that can do that. So the answer to this following is not exhibited. Yep, that should be polarization. Another question, the periodic rise and fall in the intensity of sound produced when two notes on nearly equal frequency are sounded together is called, that answer is beat. The answer is beat. The periodic rise and fall of sound wave is called beat. And which of the following characteristics of waves can a ripple tank be used to demonstrate? Reflection, refraction, diffraction. Well, from what I illustrated in that ripple tank simulation, reflection was there, refraction was there, diffraction was also there. So the answer should be 1, 2, and 3. And then last question for the day. The distance between a node and its adjacent antinode of a transverse wave is equal to. Now, let me quickly differentiate between node and antinode. Now, node is the point of minimum or no vibration, while antinode is the point of what? Maximum vibration. Now, if I have this as wave, you have wave 1, and then you have wave 2. Now, this point is called node. This point is called node, 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 node. While this point is called antinode, antinode. So by definition, this is where the two waves meet. So this is node, is the minimum, is the point of minimum or no vibration. It will be minimum if one of the wave is bigger than the other. So they just subtract, you just find a difference. But it will be no vibration if the two waves are the same. For example, if the wave that is coming here is 10 joule, and then the wave that is coming here is 10 joule. 10 joule colliding with 10 joule in opposite direction, that will give you 0. So at this point, instead of having traveling wave, you have what is called stationary or standing wave. While at this point, you have antinode, point of maximum vibration. So the answer here is a quarter of the wave length. All right. We have come to the end of physics for prep station UTME 2025. I wish you success in your exams. Thank you.